Hello YouTube viewers, welcome back to my channel. I'm Sreetips and I had a decision to make. Do I want to process the palladium that I recovered in part 15, or do I want to go ahead and try to recover the platinum from these platinum salts that I've been saving? And I've already done palladium in several other videos, so what I'm going to do today is I'm going to process the platinum salt that I have here stored up and try to get some pure platinum metal in this video. Before I go any further, boats, we got it, we received it. Thank you. Mrs. Sreetips was delighted, and I'd like to extend a thank you to all of those of my viewers who have chosen to make a contribution to my PayPal. That has helped out tremendously. I don't like asking for handouts, but it does help out and it enables me to continue to make these videos. So I just wanted to say thank you to all those who have made a contribution. All right, that's it. Let's go. Let's see if we can refine some platinum. Here is our platinum salts from several videos. I think some catalytic converter material was used to get some of this platinum, and then I got a little bit of platinum out of some other items from previous videos. What we're going to do is we're going to put the platinum salts in this beaker here and then dissolve it with aqua regia. I'm going to use hydrochloric acid to rinse it out of the container here. Here we go. Got all the platinum salt into this beaker here. Now what I'll do is add a stir bar, and we'll turn the stirring on, and I'm going to start putting some heat to it. And now what we'll do is start adding small doses of concentrated nitric acid so that we can get the salt dissolved back into solution. That was a dosage of 3 ml of nitric acid. This platinum salt is going to be contaminated with other platinum group metals. So what we're going to try to do is dissolve it, put it back into solution, and precipitate it with ammonium chloride one more time. Alright, that's 6 milliliters of nitric acid so far. Solution has started to turn colors here. It's turning a darker looking color. Okay, this is my first time doing this reaction. I've never dissolved this platinum salt before. So you're watching me learn how to do it the very first time right here. I'm going to add a little bit more hydrochloric acid, about 50 milliliters. We're going to let this cook for a while. See if I can get that platinum to go back into solution here. Alright, I've got about 200 milliliters of hydrochloric acid in here. I've added 6 milliliters of concentrated nitric acid. I've set everything up here out of the way. because what I'm thinking may happen, since this is such a finely divided material, is that once that nitric kicks in, it could cause a runaway reaction, cause the material to boil up, possibly boil out of the container. Got this standing by over here. I'm going to watch this like a hawk. If I see any kind of runaway reaction begin, I'll take the lid off and transfer it over here into this container so it will catch anything that boils over. It's been on now for about 35 minutes. I've been slowly increasing the heat. Just now I started to see a little bit of fume production in here. What I'm going to do is get a temperature reading. It looks like we've got 160.5 Fahrenheit, 71.4 Celsius. Now what I'm going to do is, I don't want to put too much in at once, but I'm going to add about another, what is that? That's about 1.5 milliliters of concentrated nitric. I'm just going to drip it in real careful here. What I'm watching for is a delayed runaway reaction here. I don't know how this stuff is going to react. This is my first time dissolving this kind of stuff. And I want to do it nice and slow, ramp the heat up slow, add the acids in real slow. And just take my time with this because it's all brand new to me. Alright, there's all the nitric. That's about 7.5 milliliters of concentrated nitric acid in there now. The solution has been on for 55 minutes now. Get a quick temperature reading here. We've got 189 Fahrenheit, 87.2 Celsius. Now what we'll do is I'm going to add another 1.5 milliliters concentrated nitric acid here. Do it real slow because that's hot down there. I don't know how this is going to react. Just drip it in drop by drop. That went in there painlessly. Alright, we've got 9 ml in there now. Okay, we're right at 1 hour. I just added that 1.5 milliliter dose of concentrated nitric acid. What I'm doing is adding small doses of nitric and then letting the yellow atmosphere in there clear up until there's no more fumes, and then I'll add another dose of concentrated nitric acid. It's been on the heat now for 1.5 hours. Let's get a temperature reading here. Got 193 Fahrenheit, 89.4 Celsius. So now what I'm going to do is add another couple ml of concentrated nitric acid here. That's about 2 milliliters going in, concentrated nitric. Adding it real slow. boy, there we go. Starting to get some reaction now. My fear is that it will take off on me and create a runaway reaction. That's what I'm trying to avoid. That's why I'm putting it in real slow here. So I've got 11 milliliters in there now. Concentrated nitric acid. The solution has been on for about 2 hours and 15 minutes now. I've been adding more nitric off camera. I've got 15 milliliters of concentrated nitric in there now. Our solution has turned from a yellow color to an orange color. I'm going to wait for these fumes to clear up in here, and then we're going to shut this down, let it cool off and settle, and see what we got. Right at 3 hours with this process, what I'm going to do is turn the stir bar off and the heat off, and we're going to let this settle and see what we got inside that beaker now. Pull this down off the heat. Okay, to verify the platinum in solution, I'm going to take this piece of filter paper on the end of a bamboo skewer, dip a little bit of our solution on it, and we're going to do a Stannis test here. And as you can see, I've got a dark orange stain, which is positive for platinum in solution. If you look here, I've got plenty of solid material on the bottom of the beaker that's settled out. I don't know if that is the filter papers and just the filter papers, or if that's more the platinum salt that hasn't gone into solution yet. What I think I'll do is put this back up on the heat, start the stir bar, and add some more nitric and see if we get some more fume production. I'm going to put our experiment back up on the heat here. And I'm going to turn the stir back on. I'm going to turn some heat back on. I'm going to crank the heat up. And we're going to add some more concentrated nitric here. See if we can get some more material to go into solution, if there's any in there. Here's 3 ml going in. 3 ml of concentrated nitric. Let's see what happens. Okay, it's been about 25 minutes since I added that last dose of nitric. And I turned the heat up on this. I've got it to 195 Fahrenheit, 91 Celsius. And as you can see, there's still some fumes being produced in here. Looks like the solution is starting to boil. So I'm going to let this go until all these fumes disappear in here. Okay, it's 6:20. I started this process at 2 p.m. It's been going now for almost 4.5 hours. Temperature's at 85.8 Celsius, 186.5. I've got 18 milliliters of concentrated nitric in there. I turn the heat off, turn the stirring off. We're going to pull this down off the heat. I think I've got everything in solution now. Pull this down off the heat and let it cool down and go from there. I've got our solution here. It's cooled down to ambient temperature. There's not very much stuff down there. That all looks like filter paper to me. So what I'm going to do is set it over here to the side. I've got a little filter set up here, and we're going to go ahead and filter the filter papers that are in our solution out of that solution. As before, I've got a magnet here. Get our stir bar attached to that so it doesn't fly out of the beaker as I'm pouring the solution into the filter here. Okay, I'm making this up as I go. As I was rinsing the filter, I realized that in order to go to the next step, I'll need to cement the metals out on zinc so that I can get a weight on them. I've got all our solution down here in this flask. What I'll do now is transfer it into this flask. And I've got a stir bar in there ready to go. Here I was setting up to evaporate the solution to a syrup, but I suddenly realized that I'm going to need to cement the metals back out of that solution on zinc so that I can weigh them. But I went ahead and evaporated the solution down to concentrate it since I had it up on the stir plate there. Okay, I've reduced the amount of liquid we have here. We'll take this off the stir in the heat and let this cool down now. And we'll precipitate out the metals on some zinc so that I can see what kind of weight that I'm dealing with here. For this next step, I realized I needed a clean, dry beaker with the weight written on it. So I got 346.2. Alright, here we go. We're going to take and transfer the solution into this beaker. That last operation was a bit of an exercise in futility because I really didn't need to evaporate this solution down. Let me go ahead and put a magnet on that stir bar. It's getting late, I'm getting tired. I'm making this up as I go, and I realized I didn't have the weight of the metal that I'm dealing with here. So I need to cement it back out on zinc, and that's what I'm going to do right now. Got some pieces of zinc over here. Going to drop these in and cement the metals back out on this zinc so that I can get a weight on the metals. This should go quickly. This is a concentrated solution, so I should make a nice fluffy precipitate of black metals that settle quickly. That piece is already gone. Just to show you how quickly this zinc is reacting in here. It shouldn't take very long. cementing the metals out with zinc. This is only taking about 5 minutes to do this. You should produce some nice, fluffy, black precipitate. It's going to be easy to rinse. And then I can dry it out and get a weight on it so that I can proceed to the next step. Okay, here's our solution. I've let it settle overnight. I went and got me some rest. And now what I'm going to do is I've got a vacuum device set up here. I'm going to suck all the solution off of here into this waste container. Here's our black metal cemented out on zinc, and what I'll do is add some hydrochloric acid and a little bit of heat and burn those excess pieces of zinc out of there. I'm going to put our platinum up here on the stir plate, add a stir bar, start stirring, and add some heat. And I'm going to put some hydrochloric acid in here now. Burn out the rest of that zinc. I'm going to add a touch more hydrochloric acid here. Get the rest of the zinc burnt out of here. Okay, the way I tell if all the zinc is gone is I turn that stir bar off, and then I look for that bubbling reaction right there that tells me I still have zinc dissolving in the solution. In fact, I can see a piece of zinc in there. So I'll just go ahead and let this react until I get no more bubbling, and that will tell me that I've got all the zinc dissolved out of the black PGM powders. This has been on stirring now for about 30 minutes or so. I've got all the zinc rinsed out of there, or burnt out of there with the hydrochloric acid. Our black powder's nice and fluffy. Go ahead and get that stir bar out of there now. Now what I'll do is I'll rinse the powder off, get all the zinc rinsed off of it. I can just pour this off now because the powdered metal stays together nicely. I'm just using some hot tap water, multiple small rinses of hot tap water here, and just try to rinse all the zinc that's on it off. And I'll just pour these rinses off. Into my waste container here. See how quickly it settles? Just do this over and over, and then I'll check it with some pH test strips to make sure all the acid has been rinsed off of it. And then it's probably fairly safe to conclude, once all that acid has been rinsed off of it, that the zinc is gone as well. Alright, I'm going to use a piece of pH test strip here. This is about the 5th rinse. And I've got it down around between 4 and 5. It's starting to become finely divided in there, so I'm going to quit rinsing here. And we'll go ahead and dry this out now. Pour this off. We'll dry this out. Get a weight on the metal. Go ahead and put it on some low heat here and dry this out so we can weigh the metal. Alright, our powder is bone dry now. Beaker's dried out, the powder's dried off there. What I'm going to do here is I've got a scale, and we'll weigh the beaker with the powder. We've got 354.9. The beaker weighed 346.2. So that's going to give us about 8 grams, 8.7 grams of platinum. Alright, write that right on here, 354.9. Alright, the desired concentration here with this much metal is going to be 8.7 grams times 20 ml. So we want this solution to be not more than 174 milliliters. We'll put it up on the stir plate here. Drop in a stir bar. Start stirring, and then we're going to add hydrochloric acid, remembering not to exceed our 174 ml target. Alright, I've had this on here heating up now for about 5 minutes, and if you look, I've already got the solution boiling, but something has gone into the solution here and caused it to turn pink. Don't know what that is. Get a little bit of it on my piece of filter paper here. I'm going to do a stannous chloride test. See what we got in solution right there. That's just hydrochloric acid in there. And it looks like that's orange, so it's a little bit of platinum going into solution with just hydrochloric acid. Boiling hydrochloric acid, I guess, has enough oxidation going on in there to put a little bit of the platinum in solution all by itself. Okay, there's a lot going on here. I'm going to turn the stir bar back on, get it stirring, and then I'm going to add some doses of hydrogen peroxide here. And we're going to get this platinum metal back in solution so that we can precipitate it with ammonium chloride. Here's the first dose of hydrogen peroxide going in right now. You can see the metal dissolving as soon as that hydrogen peroxide hits the solution. It's turning more of an orange color now. Alright, that was one dose of hydrogen peroxide, one dropper full of hydrogen peroxide. Here goes the second one, and I'll keep track of it by putting those little tick marks on the beaker there. There's our second dropper full of hydrogen peroxide going in right now. Alright, our target volume is 174 ml here. I've got less than 100 ml of liquid in there, so what I'm going to do here is add about 50 milliliters of hydrochloric acid. We'll make it 40 instead of 50. I'm just going to pour this right in so we get the level up. I think the solution can be over concentrated as well as under concentrated for the precipitation phase of this, so we got to get the concentration volume correct. Okay, I've drawn a line back here in the back of the beaker. That's the level we want to try to be at. That'll be our 174 ml of solution there. And it's kind of low. What I'm going to do here is add some more hydrogen peroxide. The nice thing about dissolving the platinum with this hydrogen peroxide is, by the way, I've got 8 of these droppers already in there. I did some off camera. But the nice thing about adding the hydrogen peroxide is I don't think you can overdo it here. If you add too much, it's not going to be a problem. Number one, and number two, there's no excess nitric acid that has to be dealt with when we go to precipitate. Okay, here's our little mark in the back there. I'm going to turn the stir bar off and see where we are relative to that mark. We're significantly below that mark. So what I think I'm going to do is turn the stir bar back on. I'm going to keep adding hydrogen peroxide. This will get the level up close to this mark. We don't want to be over it, but we don't want to be too far under it either. So what I'm going to do is keep adding hydrogen peroxide until I get closer to my mark there. Right now I've got 11 doses of the hydrogen peroxide in there. This is going to do 2 things for me. This will guarantee that everything has been put into solution, and it will get the level of the solution up to where I need it to be. Alright, I'm topping this thing off with hydrogen peroxide, a little bit at a time. Let's see if we can get it up to our target mark there. Just a touch under that mark back here, and I think that'll be just fine. So what I'm going to do is I'm going to take it off the heat here and let it cool off, and then we'll filter it and precipitate the platinum with ammonium chloride. It's coming up next. I've allowed the solution to cool down to ambient temperature, and now what we'll do is pour it through this filter. I used a little bitty filter here. so as not to tie up very much metal in the filter paper. So this is going to take a while. Got just about everything through the filter now. Got down to the bottom of the beaker. And if you look down there, you'll see that there's a little bit of black metal left at the bottom of that beaker. I've got everything filtered now. Here's some metal that's left in the beaker that did not dissolve. That might be another one of the platinum group metals, maybe iridium or something like that. I'm just going to set this up out of the way. This will get added to my stock pot. I'm going to get the filter out of here now. And then what I'll do is transfer our solution from here into this beaker so that we can precipitate the platinum with ammonium chloride. Here we go. I've got some ammonium chloride. I'm going to make a saturated solution and add it to our platinum concentrate back there in that tall 600 ml beaker. Add some still water to it. Mix it up real good, and then we're going to add it to our concentrate in the back there, and precipitate our ammonium chloroplatinate. Okay, I think I'm ready. I've got my ammonium chloride solution here saturated. That's undissolved ammonium chloride. The bottom there, up here is the dissolved. It's ice cold. That's an endothermic reaction. It gets real cold when you mix those two together. I've got a stirring rod here to help me pour it in. Here we go. We're going to precipitate the platinum. Allowed the platinum to settle. I'm going to draw off the liquid from the top of it now. This liquid's going to have ammonia in it, so I don't want to add it to my stock pot. What I'll end up doing with this is putting this in a separate container and then cementing the metals out with some zinc. I'll save the metal and add that to my stock pot. And then I'll add the waste ammonia solution to my waste treatment buckets. I'm going to get a little bit of that solution on a piece of filter paper here. And we'll do a Stannis test on this. And you can see we've got a little bit of platinum left in solution. I can see a little bit of orange, but most of that is going to be palladium. You can never get a 100% precipitation with platinum group metals. So most of that solution is going to be palladium. Okay, here's the Stannis test. All of that solution on the top, you can see it's green. That tells me we got palladium in that solution. So this, the platinum will be contaminated with some palladium. If I wanted to get it a little bit more pure, I could redissolve that salt and precipitate it one more time Every time that happens, the platinum would get a little bit more pure, but I'm not going to do that. This will be about 99% pure. I've got some ammonium chloride water. I'm putting it into the funnel here to dampen it, and I'm going to filter the platinum salt out of the beaker here now into this filter. We're going to use ammonium chloride water to rinse it into the funnel here, into the filter and out of the beaker. Got to use a solution of ammonium chloride here to rinse this precipitate out. Plain water will cause it to dissolve and go back into solution. Use the ammonium chloride water to rinse the beaker down, and then I'll add the rinse to the funnel. Try to get some more of the palladium rinsed out of that platinum salt. While I'm waiting for this to filter, I'm going to take my remaining ammonium chloride that I used to precipitate with and add it to my 15% jar here so I can use that again sometime in the future. Here's our nice platinum salt, and as I mentioned earlier, if I wanted to, I'm rinsing this down with some ammonium chloride water to rinse more of the palladium out of there. If I wanted to get this purity up on this, what I could do is redissolve this and reprecipitate it with some more ammonium chloride. Every time you do that, purity goes up. I don't think I'll be able to get it 3/9 fine using this method, but this should be very close to 99% pure, 98 to 99%. Okay, my next step here is to get that powder in a fused quartz dish, burn off the ammonium chloride, make the platinum sponge. Before I do that, I've got a slight vacuum I'm pulling on this thing. I'm trying to get as much of the liquid out of there as possible. Alright, now it's time to burn the pure platinum salt here. I've got a fused quartz dish. And this thing is very pricey. I think I paid $100 for it. If it's down in here, very nice. Fused quartz will take a direct flame. Now what we're going to do is I'm going to transfer the filter and the platinum salt into this fused quartz dish here, very carefully. So we can pull this off. that went pretty good. Okay, we're going to transfer the platinum salt over here into our little dish. And I'm going to have to start the heat real low because I've got some solution in there yet. So I'm going to put it on low and just let this evaporate down and start burning it to make the pure platinum sponge. I've had this on burning now for about 1.5 hours. We've got 300, or what is that, 435 Fahrenheit, 224 Celsius. And what I'm going to do is I'm going to swap out cameras and let the other one run for about 15 minutes and see if we can catch this thing burning pretty good and speed the footage up. All right, we're coming up on 2 hours 45 minutes here, and I've got 577 Fahrenheit, 303 Celsius, and it's just about quit smoking here. I'm going to break this up a little bit and see what we got going on underneath this little crust. I can still see some yellow right there. So we're not quite done just yet. There's some yellow colored material. We need to let that go ahead and burn a little bit longer. Right at 3 hours now. And I'm going around and poking all these little yellow pieces here, trying to get this to burn. Okay, I'm poking around in here, and I don't see any more yellow. That gray material right there is the pure platinum sponge. Everything has been burnt now. I don't see any more yellow here. And what I'm going to do now is turn this off. And we'll let it cool down a little bit, then I'll transfer it into a melt dish and we'll melt it up into a button. Alright, here we go. This is cooled down to ambient temperature now. What I want to do is bring it over here to my melt table, and we're going to go ahead and get it into this crucible right here. Alright. Just going to spoon it into the crucible carefully and try to get everything down at the bottom there so we can do a nice melt here. This is our platinum sponge. cover it with borax. Hopefully that'll help glue it in so it doesn't blow out when I hit it with that oxyacetylene flame. In this shot, I just wanted to show here that I've got two forms of eye protection to protect my eyes from the brightness of the platinum melt. That platinum will get just about as bright as the sun. And also, I'll put a welding helmet visor over the camera lens to protect the camera. This was my first time melting platinum. I started out with the torch set way low, just barely enough flame coming out of there. And then as I progressed through the melt, I kept adjusting the flame higher, adding more acetylene and more oxygen until I got the flame to where it was starting to pop almost, coming out of the nozzle. Finally, the platinum formed up into a nice little bead, and the rest is history. Here it is, bright shiny button of pure platinum. Very first one I've ever done. Put it up here on the scale. And we've got 6.6 grams. 6.6 grams of pure platinum. Well, this will conclude the platinum refining video. I had those salts saved up from the catalytic converter videos, the palladium refining video. I got a little bit of platinum salt during that video. I had the platinum salt from Stockpot video number 15. I had that all saved up in that little container. And I finally got me a little bead of pure platinum. It's going to probably be close to 99% pure. It weighs 6.6 grams. We'll put this on the eBay store and let it go for bids. That'll conclude the video. Thanks for watching.